So in this video, we're going to talk about 5 important surfaces that come up throughout multivariable calculus. And the more comfortable we are with graphing these quickly, the more our calculations go smoothly throughout the course. Really helpful throughout multivariable calculus to be able to draw a quick and accurate sketch of the different surfaces that we're going to be working with. We're going to see the details of how to do thorough graphs of these over the next 5 videos, but this video is really just an overview to show you the 5 different surfaces or 5 different types of surfaces that we'll be looking at. So first surface, if we take a multivariable function like z equal x squared plus y squared, so z is an explicit function of x and y, specifically z equals x squared plus y squared. If we were to graph all the points in 3D that satisfy this equation, we would end up with a bowl shape like this. It's actually an infinite surface, so it continues up like this, but we tend to just draw it finite so that we can see the shape of that surface. The formal name for that is called a paraboloid, but I like to think of it just as a bowl. So the important thing to realize with this surface here is that it is hollow. So we're just talking about the outer shell of the bowl. You can picture a surface as being like an infinitely thin piece of fabric that is just shaped into a bowl. So it's hollow. We're not talking about the points inside the bowl, just the very points that are sitting on the very outside of the bowl here. So in terms of our terminology here, z is a multivariable function, and the picture that we're drawing we call that the graph of a surface. Okay, so let's look at 4 other types of surfaces that are going to be coming up throughout the course, and we'll give specific names for each type of surface. So let's say we had z equal the square root of x squared plus y squared. Okay, so this specific surface is going to have a graph that looks like this. It's got straight sides like that. If we cut it off parallel to any z value, we would get a circle. So that's called a cone. And again, that's an infinite surface, so it does continue in these 2 directions here. At every height, you're getting a circle. So you could draw it continuing like that. And again, that's a hollow surface, so we're just talking about the outer shell of the cone, or the side of the cone, if you want to say that. Okay, let's look at a few more. We're going to look at 3 more, in fact, and the other 3 are going to be a little bit different in the sense that z will not be an explicit function of x and y anymore. So we're now going to talk about implicit functions. Okay, let's say we had something like x squared plus y squared equal 1. In fact, there's no z coming up in that equation at all, so we're going to have to think about this carefully. Well, if we were graphing this in 2D, we would say, oh, that's a circle centered at the origin, radius 1. So in 2D, that's what that looks like. But in multivariable calculus, we're actually working in 3 dimensions. So if we imagine what this looks like just in the xy plane, it looks like a circle. So there's our xy plane. But for every value of z, we actually get a copy of that circle. So the way we can draw this, we can draw a few pictures here. At every different z value here, we get a copy of that circle. What's being produced is actually a cylinder. So we'll see more details about this when we look in detail at the video for cylinders. You might want to call this a circular cylinder if you wanted to emphasize what the cross section looks like, but for now we'll just call that a cylinder. So that's what the graph of x squared plus y squared equal 1 looks like. And again, that's an infinite surface, so it continues up as far as we like, continues down as far as we like, and we just draw a finite portion of that to get an idea of what that looks like. Okay, next multivariable function that's going to be important. Again, an implicit function. Z is an implicit function of x and y. We're going to look at x squared plus y squared plus z squared equals 1. Okay, well, in 3 dimensions, this is actually a unit sphere. So a quick way to draw that, I usually just draw a circle and then put a curvy arc on here just to show a bit of perspective. So we'll write down the name. That's a sphere of radius 1, centered at the origin. So that's another good one to know. And then last of our 5 surfaces that we're going to look at here, let's take something that has an equation like 3x. Oh, so let's write that up here. 3x plus 2y plus z equals 6, for example. So to imagine what this looks like, we could think about the different intercepts of our variables here. So if we think about our x-intercept, x equal 2 would lie on that surface. Y equal 3 when x is equal to 0 and z equals 0 would lie on that surface. And then if we think about the z-intercept, so now we're talking when x equals 0 and y equals 0, what would z be? Z would be 6. So that point right there lies on our surface. And the specific surface that's resulting here is a plane. So usually when we think about drawing a plane, we find 3 points that lie on that plane, and then we just form a triangle out of those 3 points. And that's a good way of visualizing which plane we're looking at in 3D space. It gives us a sense of how that plane is tilting in space. Again, this is an infinite surface. So if you start to draw the plane, it actually continues infinitely in this direction, in that direction. So it's just an infinite rectangle tilting through space, but the triangle is really the best way of visualizing the points, gives us a cleaner way of visualizing that plane. So as a summary of our discussion, when we graph a multivariable function, what we produce is a 2-dimensional surface within 3-dimensional space. So these surfaces are hollow. I like to think of them just as an infinitely thin piece of fabric that has been stretched or shaped into a certain form. And let's look at the 5 important surfaces that we looked at here. So we had the paraboloid and the cone. Those were 2 situations where z is an explicit function of x and y. And then we saw 3 other surfaces that were defined by implicit functions. We saw the cylinder, the sphere, and the plane. So we'll see more details on each of these 5 important surfaces in some upcoming videos. Thanks for watching.